Hello everyone and welcome back to another video of competitive programming. Today we'll be doing a British Informatics Olympiad question taken from the 2011 question 1. So let's just quickly see the question. So the question is basically Fibonacci letters. Each letter can be given a value based on its position, 1 to 26, A being 1, Z being 26 obviously, and how it works is this sequence is similar to the Fibonacci sequence because we start with 1, 1, and then we go 2, 3, 5, each time just adding the two numbers before it. But this is the same thing except with the letters. So AA is like 1, 1, and then B becomes 2, C becomes 3, and E is formed from adding B plus C, so 2 plus 3 becomes 5, etc., etc. And now, what the question is asking is for us to print the nth Fibonacci number. So this basically, we accept two inputs of the first two letters, and then we need to print the seventh, for example. So now, one key observation in this question is that n can be from anywhere between 1 and 1 million. If n was a small number, like let's just say 10,000, I know it's not small, but like for a computer, 10,000 is pretty small. We could just like brute force it. We could literally just do it. We could just generate each number from 1 to 10,000 and then print the nth number as soon as we reach the 10,000th break and then print the 10,000th. We can't do that for a million. A million is too large. So we can't do a brute force. We need to be a bit smarter about it. So here it is. So we basically just take these 3 lines are just taking the input. We take the first 2 lines, we take the first 2 lines as shown in the question. The first 2 are the first initial numbers inside, and the third is the nth number which we need to print, okay? So we take the first 2 and the nth, we convert this into an array. This array will be the, the array which I was talking about the unique array, which will be the cycle eventually, pretty much. So these are the first 2 elements, and I'm outputting these in the numerical format. So A becomes, this is the ASCII value of A. If you're not familiar with ASCII values, it's basically how the computer internally stores A. It stores capital A as 65, and if we subtract 64, A becomes 1, B becomes 2, exactly how the question wanted us to solve the numbers, right? So, the reason I'm doing this is it becomes much easier to add 1 plus 1 to become 2 than for A plus A to become B, right? So then A and A will become 1 and 1. And this can be generalized to any number. It will become its ASCII representation. And now I'm just converting I will come to later, and repeat to being 0 and n to being the integer version of n, so the nth number. So I is basically just the iteration number as a standard programming procedure, and we need to do while I is less than n, so while the number which we're currently on is less than the nth Fibonacci number, and repeat equals 0. So if we didn't have this code, if we didn't have this, and if we weren't checking for repeats, it would be a brute force, which wouldn't be sufficient. But what this repeat does is it checks if the value of the repeat is 0. If the value of repeat is 0, then we know that repeat has not been found yet. Okay? A repeat has not been found yet. And then after that, what we do is each number, we append the previous 2 numbers. So the second last element and the last element in the array, we append the sum of the 2 numbers. If it's greater than 26, we subtract off 26, as we discussed. And if the final element is equal to the initial element, which basically means that we've found a repeating cycle. And the key thing here is that if the second last element is also equal to the first element. If we didn't check for this, then we would basically just break if 8 was 8. Like, for example, if we go back to the whiteboard quickly. Sorry, just give me a second. Both, if the second last and the last one are both the same, okay? And if they're the same, then we set repeat equal to the ith number minus 1, okay? So it means that, like, let's say we found a repeat in the 25th number. So it means that the first 24 numbers are a repeat. And now we just pop the last 2 elements, the last 2 elements being the 2 duplicate elements, since they're the same as the first 2 elements, right? And then now the repeat is set to a non-zero value. In the subsequent iteration, we won't be in this while loop again, okay? We'll break out of this while loop. Okay, I hope you're like following so far. And now if repeat equals 0, which we haven't found a repeat yet, we basically just print the nth number. This is back to, let's say if we print the 5th number and we haven't found a repeating cycle yet. So, but now if the repeat is not equal to 0, which means we have found a repeating cycle, we basically print the nth number in some mod, and this mod will be the repeat. Since we know that every ith characters, I being the repeat characters, will repeat. And then we do -1, because indexing starts from 0 in like general programming procedure. So we can't just print this, we need to print the -1th. And now all of this will basically give the numerical value, like let's say it'll give like 3 or whatever. But we need to then print the character form, +64, which will be 3 plus 64, which will be the ASCII value of 67, which will be C. This character just converts back to the ASCII, this odd converts from the character back to its numerical notation. So this basically, if we just test it on our sample input, where does the sample input go? AA7. We can see that it basically works here. It gives the nth character. And now if we test it on some of the larger test cases inside the log scheme. So this current value has 10,000 pretty much. Now 10,000 would probably work for a brute force code as well. Like if we didn't have this whole repeat logic, then we would have still passed. But so it currently gave C, which we can see is the same as what the mark scheme has. It is C. And now for this final one, BI987654. Now our code outputs very quickly here. Like it will probably output in like 10 milliseconds or so. If we had a brute force code, this would take a few seconds at least. And as you know, for the British Informatics Olympiad, if you have any more than like a couple of seconds, it will not pass. It will basically fail. So, and now outputs W as expected. If we go back to the sample, we have W, which is what the correct output is. Now, I'll basically leave the code in the description in case you want to test it out for yourself, and if you want to like just play around with it, modify a few values, just so you can like properly understand it. Excuse me, but that's basically it for this video. I hope you learned something from this question one. It was quite a neat question in requiring like the nth number, and we couldn't just use a brute force logic as we could with some of the others. And if you learned something, please be sure to leave a like and subscribe. It would be greatly appreciated. And if you want to check out the code, feel free to check out my GitHub repository, which will be in the link in the description below. Okay, thank you. I hope to see you in another question.